Okay, so in this lesson, we're going to look how to graph absolute value equations using horizontal shift. Now, in the previous lesson, we graphed absolute value equations that involved vertical shifts. So, for example, examples from the previous lesson, let's say these are examples of vertical shifts. So we have y equals the absolute value of x plus 5. All right, so what that means is this. So remember in the previous lesson, if we graphed the absolute value of x, and that was this right here. So here was the absolute value of x. Okay, so where the vertex is at the origin. In the previous lesson, if the number's on the outside, you see where I have the absolute value of x, and then I'm adding a number, I'm adding 5, then what that meant was I would shift this up 5 units. 1, 2, 3, 4, 5. And so that would be the graph of the absolute value of x plus 5. Okay? Then another one we could have done was y equals the absolute value of x, let's say minus 7. The absolute value of x minus 7. So if this is the absolute value of x, okay, then what do you think the absolute value of x minus 7 would look like? Well, that would be a shifting down 7 units. 1, 2, 3, 4, 5, 6, 7. And so notice the vertex is at negative 7 on the y-axis. So that would be the absolute value of x minus 7. What we want to do now, though, is this. So I know that a vertical shift occurs if I have a number on the outside. So that would be a vertical shift up 5 units, up 5 units. And this would be where I take the graph of the absolute value of x and shift it down 7 units. Okay? But what I'm going to do now is talk about horizontal shifts. So let's talk about the horizontal shifting. Okay, so a vertical shift occurs if the number's on the outside. Okay, horizontal shifts occur if it looks like this. So we have y equals the absolute value of x plus a, something like that, or y equals the absolute value of x minus a, something like this. So it'll look like y equals the absolute value of x plus 3, or y equals absolute value of x minus 3. All right? So it looks something like that. So that's horizontal shift. So that's a horizontal shift where the number appears within the absolute value bars. The number appears within the absolute value bars. Vertical shifts occur when the number's outside the absolute value bar. So you have absolute value of x and then plus 5, absolute value of x minus 7. So notice here, the number's on the inside. So that's not a vertical shift. That's a horizontal shift. So let's see what that looks like. So let's go ahead and let's do this one. So let's graph y equals absolute value of x plus 3. And we're going to do this by using a t-table. So use a t-table. Now remember in the previous lesson, we looked at the vertex. So remember the vertex. So in each case, in the previous lesson, so this is absolute value of x, the vertex with the origin. If I shift it up, down, the vertex is still on the y-axis, right? The vertex on the y-axis. So shifting up or down, the vertex is on the y-axis. And x, no matter where you're on the y-axis, x was always 0. So in the previous lesson, when we did the vertex, when we did the vertical shift, we always let x equal 0. Okay? When doing this one, I'm going to do the same thing. First thing I'm going to do is let x be 0, although you're going to notice that that's not where the vertex will be. Okay? So keep that in mind. So that's a horizontal shift. The vertex is not going to be when x is 0. But I'm still going to use it. So if x is 0, I get y equals absolute value of 0 plus 3. So we do what's inside the grouping symbol. 0 plus 3 is 3. So it becomes the absolute value of 3, which is 3. If x is, let's say, 2. If x is 2, I get y equals the absolute value of 2 plus 3, which is the absolute value of 5, which is 5. All right, so I'm going to go ahead at this point and start plotting those points and see what happens. So here's 0, 3, right? Here's 0, 3. Here's 2, 5, right here. And so remember, the graph is the shape of a V. So when we talk about absolute values is the shape of a V. So either it's going to open up or it's going to open down. Okay, open up or open down. But the shape is a V. So it's very helpful if I can find that vertex. So I know that the graph is shape of a V, so it has to do this. So I know that the vertex is on this side, right? The vertex is on that side. See how it looks? So the vertex can be somewhere on that side. So I want you to notice this. So let's think about this now. So you may say, then what do you think is going to be the next number? Well, letting x be 3, 7, 8 is not going to be very helpful. Will not be helpful. Because remember we said that the shape of a V, so that's where the two rays meet. So I know that the vertex will be somewhere around here. And here's what I want you to think about now. You see this number right here? Positive 3, x plus 3? Think the opposite. Think the opposite. Opposite. So what's the opposite of that positive 3? Negative 3. So let's see what happens with negative 3 now. Okay? So if x is negative 3, I get y equals the absolute value of negative 3 plus 3. Negative 3 plus 3 is 0. The absolute value of 0 is 0. So when we had the discussion about vertical shift, we said that the vertex was going to lie on the y-axis, right? So if this is the absolute value of x, and I'm looking at horizontal shifting, okay, then the vertex is going to lie where? On the x-axis. So if I have a horizontal shift, that vertex is going to lie on the on the x-axis. Vertical shift, vertex lies on the y-axis. Horizontal shift, vertex lies on the x-axis. And remember, no matter where you are on the x-axis, what's that y-coordinate? So this point right here, if x is 2, what's that y-coordinate? 0. If x is 3, what's that y-coordinate? 0. If x is 4, what's that y-coordinate? 0. So notice that when I look at a horizontal shift, just a horizontal shift, then my y-coordinate is 0. So this is going to be your vertex right here. That's going to be your vertex. Now keep in mind that's only true if we're just doing a horizontal shifting. Okay? If we're doing a horizontal shifting. Notice that there is no vertical shift here. No vertical shift. Since you don't see a number on the outside. So you don't see a plus 5, you don't see a minus 3, anything like that. So there's no vertical shift. So that means that I'm only involving a horizontal shift. Okay? All right. So let's plot some more points. So I know now that this is my vertex, right? Y'all agree? Okay, so that means this. So that means I know what one of my rays looks like. One of my rays looks like this. Okay, now let's do the other one. So I know that now it's going to go up like this. So let's say negative 5. Let's do negative 5. If x is negative 5, I get y equals the absolute value of negative 5 plus 3. Negative 5 plus 3 is a negative 2. The absolute value of negative 2 is a positive 2. So I get negative 5, 2. So negative 5, 2 is here. And really, that's enough. I know what it looks like now. So I'm going to go ahead and draw that ray. So I get something that looks like this. So this is the graph, y equals absolute value of x plus 3. So a lot of students get confused here because absolute value of x, the absolute value of x plus 3, note, y equals absolute value of x plus 3 is a shift of absolute value of x up 3 units. Okay, so that means this. That means that this right here would be, right here, that would be the absolute value of x plus 3. The absolute value of x plus 3 inside the absolute value bars is counterintuitive of what you would think. So you see that plus 3 means you go up. If that was a minus 3, you go down. students get confused here. See how that 3 is on the in the inside? And so they want to think, well, should I go to the right 3 units? No, it's counterintuitive. And you see when you plotted points that it was really going to the left. So if this is the absolute value of x, then the absolute value of x plus 3 is you're going to go to the left 3 units. 1, 2, 3. So it's counterintuitive. Counterintuitive. Okay, so just what I would do is I would look at, see that plus 3, I would think the opposite, negative 3. So I would shift it to the left 3 units. Your vertex is at negative 3. Okay? All right, so notice we use points to plot the graph. Okay, we use points to plot the graph. We also use the idea of horizontal shifting to help us to understand why the graph looks like this a little bit better. So here's the absolute value of x, and the absolute value of x plus 3 is a horizontal shift. Since the 3 is on the inside of the absolute value bars, it's a horizontal shift to the left 3 units. Okay? Let's look at this now. What if we had the absolute value of x minus 3? The absolute value of x minus 3. So let's graph the absolute value of x minus 3. So let's go ahead and call this number 1, and then this would be number 2. Okay, so y equals the absolute value of x minus 3. So I want you to notice that this is going to be a horizontal shift. Horizontal shift of the absolute value of x, of the graph of the absolute value of x, because it's on the inside. But counterintuitive. So my question to you is this. If this is the absolute value of x, okay, if that's the absolute value of x, and we know that this is a horizontal shift, am I going to go, and remember, you always look at this number to tell you what the vertex is. So here's my vertex right here for absolute value of x. Am I going to go to the right 3 units or to the left 3 units? To the right 3 units or to the left 3 units? Counterintuitive. See that negative 3? Think the opposite. Positive 3. So you can go to the right 3 units. So what I would do is this. So remember, when all we're doing is a horizontal shift, if all we're doing is a horizontal shift, then the vertex lies on the x-axis, right? The vertex will lie on the x-axis, which means that my y-coordinate is 0. My y-coordinate is 0. Y'all agree? Okay. So, if I let x be 3, isn't my y-coordinate 0? Y equals the absolute value of 3 minus 3. If x is 3, I get 3 minus 3. 3 minus 3 is 0. What's the absolute value of 0? 0. So that's your vertex right here. So your vertex is 3, 0. So that's where your vertex is. So you know that the graph's going to look something like this. Okay, so that's your vertex. You know it's going to look something like this. So let's go ahead and just plot a few more points just to plot points, because you do want to still do this by plotting points. So if x is, let's say, 4, I get y equals the absolute value of 4 minus 3, which is the absolute value of 1, which is 1. So I plot the point, 4, 1. Let's do another one this side. Let's say 6. I get y equals the absolute value of 6 minus 3. 6 minus 3 is 3. The absolute value of 3 is 3. So I plot the point 6, 3 right here. So now I have something that looks like this right here. And then let's pick some points on this side. Let's say 1. If x is 1, I get the absolute y equals the absolute value of 1 minus 3. 1 minus 3 is a negative 2. The absolute value of negative 2 is positive 2. So I get the point 1, 2. And so I just connect those, and I get something that looks like this. Which kind of made sense, right? because when we look at this in terms of shifting, here's the absolute value of x, here's the absolute value of x. So if I want to graph y equals the absolute value of x minus 3, and notice there's no vertical shift, it's just horizontal because there's no number on the outside, then I'm going to go to the right 3 units. So I get something that looks like this. Okay, so counterintuitive. All right, now let's in the previous lesson we looked at domain and range. Let's still continue talking about domain and range. So remember when we plotted these points, we could have chosen any number for x, any real number. -8, -92.7 decimals, fractions. I could have chosen 8 4/5. All right, but we chose integers. We chose integers. Okay, we chose integers because we wanted the outcome. We wanted the y coordinates to be integers, so that way it would make things a lot easier to graph. We didn't have to estimate. Okay, so knowing that remember the domain set of x coordinates. So notice that for the domain, I could have chosen any number for x, any real number for x. So the domain will be any real number. So -infinity to infinity in terms of interval notation. So all real numbers is my domain. Okay? The range is not all real numbers though. Because remember, the range is a set of y coordinates. So if I look at all these points, on the graph, at the y coordinates, do you see that this is the smallest y coordinate? And what's that y coordinate right here? 0. So when talking about the range, you go along the y-axis, and I start touching the graph when I get to this vertex. What's that y coordinate? 0. And notice that that's a point of the graph, so I got to use a bracket. So my range will be bracket 0, comma, and then I'm going all the way. No matter if I look at 6, I'm going to get a point on the graph. So there's going to be a y coordinate. There's going to be a point where my y coordinate is 6. There's going to be a point where my y coordinate is 100, 2,000. So I'm going from 0 all the way to infinity. And remember, when we use infinity, -infinity, notice the parentheses. We all use parentheses with domain and range when we use parentheses, when we use infinity and -infinity. Okay? All right, let's look at this example now. Suppose now, so we know the idea of horizontal shifts. So we know what horizontal shifts look like. Okay? So now let's suppose we had this though. So number 3. What if I had y equals the absolute value of x plus 5? Okay, so we know that's a horizontal shift, right? Okay, because the number's on the inside. Here's the question though, is this. Is it going to be a horizontal shift to the right or a horizontal shift to the left? It will be a horizontal shift to the counterintuitive to the left. So I'm going to shift the absolute value of x to the left 5 units. So I'm going to shift the absolute value of x to the left 5 units, meaning this. So remember the absolute value of x, the vertex of the origin. So now, if I move this to the left 5 units, 2, 3, 4, 5, my vertex is now -5, 0. Okay? So remember, the first thing I always ask you to do is to find the vertex. So since this is a horizontal shift, the vertex will occur when x is -5. -5. That's where the vertex will occur. Hopefully, if you didn't make a mistake, the y coordinate will be 0. So let's see. So I get y equals the absolute value of -5 plus 5. -5 plus 5 is 0. And what's the absolute value of 0? 0. So that's correct. My vertex is -5, 0. And then all I got to do is just pick 2 points on this side, 2 points on that side, and I draw my graph. Okay? So let's say -3. If x is -3, I get y equals the absolute value of -3 plus 5. Negative 3 plus 5 is 2. The absolute value of 2 is 2. If x is, let's say, 0, I get y equals the absolute value of 0 plus 5. 0 plus 5 is 5, and the absolute value of 5 is 5. And so remember, when you let x be 0, you're actually finding the y-intercept. That's the y-intercept when you let x be 0. So notice, if I go ahead and plot those 2 points, negative 3, 2 is here, 0, 5 is here. All right, so that's where the graph's going to cross the y-axis. And notice I have now this ray. So I have this ray. All right, so there's a vertex. I know that the other side then is going to do this. So let's just pick one more point on that side. So let's say negative 7. So if x is negative 7, I get y equals the absolute value of negative 7 plus 5. Negative 7 plus 5 is a negative 2. The absolute value of negative 2 is a positive 2. So I plot the point negative 7, 2, and I get this. All right, and so there's your graph. Now you got to make sure it looks symmetrical about that vertex. Okay, so if you make a mistake and it looks like this, you know that cannot look like this. It's got to look like a symmetrical V. All right, so if you look at this right here, if I draw an imaginary line through the vertex, then it's got to look symmetrical about that vertical line. Okay, so just make sure you draw your V correctly. All right, so this is the graph y equals the absolute value of x plus 5. Okay? What if we had this? Number 4. Oh, forgot. Let's talk about the domain and range. So the domain is going to be all real numbers, right? Negative infinity to infinity. The range was the smallest y value. Don't forget your arrows. What's the smallest y value? 0. So I'm going from 0 all the way to what? Infinity. So bracket 0 to infinity. What if we had this, number 4? Y equals negative absolute value of x plus 2. Negative absolute value of x plus 2. Okay, so you got to remember something from our previous lesson. The negative on the outside makes the graph open down. So it's going to go down. So that's what that negative does. The negative opens the graph down. So remember that opens down. So you're going to get a graph that's going to look like this. Okay? So think this. So that negative makes it do this. All right? Makes it open down. The horizontal shift is still the same. So if I cover this up, always do the negative last. So if all you had was this, then that would be a horizontal shift which way? To the left 2 units. Okay, to the left 2 units. So this would be shift absolute value of x to the left 2 units, right? And then reflect. And then reflect, meaning when I shift it to the left 2 units and I reflect, I get this. So you can see it's going to happen. So let's look at this in terms of a coordinate plane. All right, so let's think about this. All right, so remember that negative on the outside is a reflection, so it opens down. Okay, so here's the absolute value of x. So if I want to graph the absolute value of x plus 2 only, then that means I go to the left 2 units, right? 1, 2. So I know where my vertex is. So my vertex is at negative 2, 0. But then I'm going to reflect it about that vertex, and I get this. So at the end, I better get a graph that looks like this, all right? You better get a graph that looks like this. So when you plot your points, always think about where your vertex is located. And since there's reflection, your ray is going to be in quadrants 3 and 4, meaning that those y coordinates are what kind of y coordinates? Negative. They're negative y coordinates. So remember, in quadrants 3 and 4, those y coordinates are all negative, right? Okay. So, first thing I do, when all you have is a vertical shift, a horizontal shift. Horizontal shift is look at the vertex. So let's do a t-table. Your vertex is going to occur when x is what? Counterintuitive. When x is what? Negative 2. So I get y equals and now remember, in the previous lesson, think of this instead of say negative absolute value of x plus 2, think of this when we do the computation, the opposite. So the opposite of the absolute value of negative 2 plus 2. Negative 2 plus 2 is 0, so this becomes the opposite of the absolute value of 0. The absolute value of 0 is 0, so this becomes the opposite of 0, which is 0. So I'm plot the point, negative 2, 0. So that's here. Okay? Now remember, it's a reflection. It's a reflection, so I know that my graph's going to do this, right? I know it's going to do that. Okay, so let's pick another point. Let's say if x is 0. If x is 0, I get y equals the opposite of the absolute value of 0 plus 2. So in place of x, I substitute 0. 0 plus 2 is 2, so I get the opposite of 2. The opposite of the absolute value of 2. The absolute value of 2 is 2, so this becomes a negative 2. And remember, we know that since there's going to be a reflection, all these y coordinates better be what kind of numbers right here? It better be negative. And so we do. So 0, negative 2 is here. Let's do one more on this side. Let's say 2, if x is 2. If x is 2, I get y equals the opposite of the absolute value of 2 plus 2. 2 plus 2 is 4, so it becomes the opposite of the absolute value of 4. The absolute value of 4 is 4, so this becomes a negative 4. So 2, negative 4 is here. So I know now what the graph on this side looks like. So the graph on this side looks like this. Okay, and so remember in your mind is what you had, right? Okay, so it's overlapping, so I just got to find 1 or 2 points on that side. So let's say if x is negative 3. Negative 3. So if x is negative 3, I get y equals the opposite of the absolute value of negative 3 plus 2. Negative 3 plus 2 is a negative 1, so this becomes the opposite of the absolute value of negative 1. The absolute value of a negative 1 is 1, so this becomes a negative 1. The opposite of a positive 1 is a negative 1. And so notice I've plot that point, I get this. So I get this graph. And so that's what we said earlier, didn't we? So if I want to graph the negative absolute value of x plus 2, cover the negative up right now. So this says I take the graph of absolute value of x and shift it to the left 2 units. So I'm going to shift it to the left 2 units, and then the negative is a reflection about the vertex. Okay? All right, so this is y equals negative absolute value of x plus 2. Now let's talk about the domain and range. So the domain is all real numbers. And let's talk about the range. Okay, now notice the arrow's opening down, right? Okay, so whenever you talk about the range, that's a set of y coordinates. The range is a set of y coordinates. So notice that these y coordinates are getting smaller and smaller and smaller. So I'm going from negative infinity all the way, and this is a maximum y value. So when we did the other one, the vertex, the y value was a minimum, was the smallest. So notice I went from 0 all the way to infinity. Here, though, I'm going from negative infinity all the way to 0. So negative infinity all the way to 0 with a bracket on 0. Okay? All right, let's look at this one. Suppose in number 5, we had this. In number 5. Suppose we have the opposite of the absolute value of x minus 3. The absolute value of x minus 3. Okay, so remember, this is a reflection, so you know your graph, your absolute value, the v is going to be pointing down, right? So it looks something like this. Okay, let's do this first. So is this a horizontal or a vertical shift? Notice it's on the inside, so it's going to be what kind of shifting? Horizontal. So either you're going to go to the left or the right. What do you think you're going to do? You're going to go to the left 3 units or to the right 3 units? Counterintuitive, think the opposite, to the right 3 units. So you're going to shift the absolute value of x to the right 3 units. So in other words, if you look at the graph, so if this is the absolute value of x, I'm going to shift it to the right 3 units, right? But then there's a reflection, right? There's a reflection. So then we're reflected about the vertex. That's where the vertex is right now. So I'm reflected about the vertex, and I get this. So when I graph it, I better get something that looks like this. Okay? All right. So let's go ahead and do this. Let's do a t-table. So the first thing you want to do is find the vertex. So to find the vertex, you're going to let x be the opposite of what you see here. So I'm going to let x be 3. So if x is 3, I get y equals the opposite of the absolute value of 3 minus 3. 3 minus 3 is 0. So it becomes the opposite of the absolute value of 0. The absolute value of 0 is 0. And the negative 0 becomes 0. So I plot the point 3, 0. Which I knew that's where my vertex was. And now I know it's going to be pointing down because of that negative out here. That's that reflection. So I just pick 2 points on this side and 1 or 2 on this side. So if x is, let's say, 5, I get y equals the opposite of 5 minus 3, the absolute value of 5 minus 3. 5 minus 3 is 2. So it becomes the opposite of the absolute value of 2. The absolute value of 2 is 2, so it becomes a negative 2. So 5, negative 2. So I know that it had to be below the x-axis, right? Because it's doing this. So in my mind, I know that it has to do something like this. If x is, let's say, 7, I get y equals the opposite of the absolute value of 7 minus 3. 7 minus 3 is 4. So it becomes the opposite of the absolute value of 4. The absolute value of 4 is 4, so it becomes a negative 4. So 7, negative 4 is here. And I'm going to use my ruler now. And so I know what this ray looks like. So this part of the graph looks like this. Okay, now let's do this side. So I know on this side it's got to do this, right? Okay, but don't just draw a ray without plotting some points. Okay, you got to plot at least 1 point. Let's say 2. If x is 2, I get y equals the opposite of the absolute value of 2 minus 3. 2 minus 3 is a negative 1, so it becomes the opposite of a negative 1. The absolute value of a negative 1 is positive 1, so it becomes a negative 1. So I'll plot the point 2, negative 1. Let me go ahead and use a negative number just to show you what's going to happen. If x is negative 1, I get this. I get y equals the opposite of the absolute value of negative 1 minus 3. What's a negative 1 and a negative 3? A negative 4. I get the opposite of the absolute value of negative 4. The absolute value of negative 4 is a positive 4, so it becomes a negative 4. And so I plot the point negative 1, negative 4, and I get this. Now we can draw a ray. It looks something like this. So let's think about what we said. So if I want to graph, this is supposed to be the graph of y equals the opposite of the absolute value of x minus 3. So if I want to graph this right here, remember there's going to be a horizontal shift, counterintuitive, to the right 3 units. So I'm doing this. So I'm taking the absolute value of x, I'm shifting to the right 3 units, and then the negative is the reflection. So always do the reflection last. Always do the reflection last. So I'm reflected about the vertex. So I get this. Okay? All right. So let's talk about domain and range. So domain is going to be all real numbers. Okay, so notice that I could have chosen any value for x. If I would have chosen 100.7, I would have gotten a y value. If I would have chosen negative 1 million, I would have gotten a y value. So the domain's any real numbers, but the range is not. So notice the arrow, the V is pointing down, right? So the graph's pointing down. So that means that this vertex is going to be the largest y value. So when finding the domain and range, always go from smallest to largest. So notice if you go back to all the domains, I put negative infinity first and then positive infinity last. Okay? So I always go from smallest to largest. I'm going from negative infinity to the largest y value. And what's that largest y value? 0. So my range is parentheses negative infinity to 0 with a bracket. Okay, so that takes care of horizontal shifting. All right, so remember, vertical shifting occurs if you see a number on the outside of the absolute value bars. Horizontal shifting occurs if the number's on the inside. Okay? All right, so that takes care of horizontal shifting. Now what we're going to do the next lesson is this. So in this lesson that we just did, we did horizontal shifting. So the absolute value of x, the vertex was at the origin, so I went either to the right or the left. Sometimes there was a reflection, but you still went to the right or the left and then were reflected, right? The vertex in either case was always going to be located where? The vertex was going to be located on the x-axis. In the previous lesson, those were vertical shifts. So the vertical shifts, the vertex was located on the y-axis. Now what we're going to do in the next lesson is put those two together. So you're going to have a horizontal shift and then a vertical shift. So notice the vertex is no longer on the x-axis or the y-axis. It's somewhere in a quadrant.